Hey, good evening, everyone. Thank you so much for coming. This is really awesome. Like 2 weeks ago, less than 2 weeks ago, we thought, we were getting together all the Jest core contributors from all over the world to hang out here and work together for 2 days to just think about, where Jest is going to go, and just like hack together and have a lot of fun. And then, just 2 weeks ago, we were like, okay, wouldn't it be also awesome if we take this time to all get here on stage and just share with you all the stuff that we have been working on, and just give you like an update, and we'll have a couple of cool announcements for today. So thank you so much for coming. Thank you. So today's event is about delightful JavaScript testing with Jest. Just to introduce myself, I'm Christoph, and I'm very fortunate to work with an amazing team, a JavaScript infrastructure team that works on 3 projects called Metro, Yarn, and Jest. So Jest is the JavaScript bundler for React Native. Actually, people who use React Native use Metro automatically, and it's more in the background. And we haven't really gone out there to talk about Metro much in the open source community. You can expect that to change starting next week at JSConf EU, where Miguel from the JavaScript Foundation team here in London will be talking about how we scale JavaScript build systems for React Native, which is going to be super exciting. And then, Jest is about delightful JavaScript testing, and then, Yarn is a JavaScript package manager that we built to manage dependencies, third-party dependencies. But, today, the focus of the event is all about Jest. If you guys want to hear about like Metro or Yarn more, then maybe in the future we can do events on those. So we take care of these 3 projects that are all foundational tools, foundational JavaScript tools that make JavaScript engineers at Facebook effective. And so we work on a bunch of different things, and that's like super exciting. But just to talk a little bit about what delightful testing or delightful tools actually are, I think there are 3 key things that tools like that in that category need to fulfill. First off is obviously performance. If a tool is not fast enough, just nobody's going to use it. It has to have a rich feature set for whatever given definition of feature set. But then the last thing is usability, and that's something that we as front-end engineers here at Facebook really focus on, because that's something that sets tools apart from other tools, right? Like if all else is equal, the things that drive people to use a certain product is the experience that you have when you use them. And for Jest, there's a bunch of things like the attention to detail that went into making those beautiful error messages and the meaningful output at the end when you finish a test run. And we focused a lot on putting users in control and like just getting the UX just perfect. And if you have used Jest, I'm not sure if everybody has used Jest before. If not, please give it a try, but it's also really just a lot of fun to use. And then before we kick off the talks, I just want to talk a little bit about the Jest community. So Jest is an open source project, and open source only works with really amazing contributors. Today's event is all about celebrating those contributions by external contributors, but also by Facebook engineers. And they all work on making Jest awesome, and we at Facebook benefit a lot from that, but also the JavaScript community does. So Facebook's mission, I'm just getting a little bit cheesy here and like tying this all back to why are we doing even this open source thing, right? Like what is the point of all this? But our company's mission is to give people the power to build community and bring the world closer together. And I believe that this really applies to building strong open source communities as well. Jest has recently become one of the most popular JavaScript test runners. And I really want to make sure that we build sustainable communities around these open source projects that a large part of the JavaScript community depends on. So, this is why I'm happy to share that we're starting an open collective for Jest today. So you can go to that link. And the amazing thing for that is that Facebook will actually donate about $1,000 every month to enable Jest core contributors to go to conferences, to promote the Jest project, to help maintain the project. We'll use it to pay for speaker travel, and we'll just get more T-shirts printed and get those under people's hands. The caveat here is, that we set this up so that Facebook employees obviously are not going to be, benefiting from this, because that wouldn't make any sense. So this is purely for external contributors that spend their free time hacking on Jest and building awesome stuff that everybody in the community and we at Facebook benefit from. So if that is, thank you. Thanks so much. So we're working on developing a bug bounty program around that as well. I don't know exactly what that's going to look like or if we will ship that, but we'll share news when we have it. And for now, we'll just prototype this approach with Jest. And we haven't figured this out yet. This is just something we're going to try. And if you have feedback on how we can get this right, then please let us know on Twitter or get in touch with me after the event or whenever. So we're just really interested to see how this can help the project be more successful and just provide a better experience for everyone. And in the end, just execute on this mission that the Jest project has, is to just get people to write more tests and build stable software, and that's what we all hear about. All right, just to actually kick off the event, just going quickly through the agenda. So the first talk is going to be Aaron, and he's going to talk about writing meaningful tests. And then Rick is going to talk about blazing fast snapshot testing in Jest 23. So all the buzzwords that went into that title. Then we'll have a very short break, and then we'll have 4 lightning talks. So Simen, we're not exactly sure how to pronounce his name. We'll talk about Jest's delightful error messages. And then Matt is going to tell us about leveling up your Jest experience with a bunch of community packages. Michele is going to talk about snapshotting all the things. And then at the end, to round it up, when you have heard just enough about testing, we'll talk about Webamp, which is a super fun and exciting project that Jordan has been working on. All right, so that's it from me. So I'll just ask Aaron to kick off the first talk. Thank you so much.
Hi, everyone. My name is Aaron Abramov. I work at Facebook, and most of my time I spent working on test infrastructure, writing tests, help people write tests, and build better infrastructure for our tests at Facebook. For probably about a year, I worked on Jest. Me and Christoph shipped a lot of major versions. That was awesome. And today I want to talk about writing meaningful tests. And to understand what meaningful tests are, I want to start from this chart. That is really, really, really important to me, and I use it every time I start working on any of the new projects. So this chart shows how much coverage, or code coverage, or you can treat it as code quality or code stability, we get based on the amount of time we spend writing tests. And so this chart shows that it's really easy to start writing tests, and even if you create just one test, you kind of get like 40% coverage, and you already know that your application can load, you can require your file, and it kind of gives you pretty good confidence that your code works. And then as you start writing more and more tests, you kind of hit this diminishing returns problem where every new test is it's harder and harder to write, and when you start finding those edge cases, they're really hard to test. And every time you try to test a new project, you need to find this sweet spot, which is a compromise between how much stability do you want versus how much time are you willing to spend on writing your test. And for different kind of application, it's really different. If you work in a financial area and you work on a bank application, you probably want your application to be really stable. And you should be probably on the right side of this chart, a lot of tests, a lot of stability. If you work on a general web application, sometimes it makes sense to fix the bug in production instead of spending 2 weeks writing the test to catch the bug that might not even be a bug. If you write internal tools, you don't test your applications at all. And you somewhere here. So then there's another chart. Every kind of test gives you different coverage. On the left side, you have unit tests, which is you create one test, but it tests only one function, and you don't really have any coverage. And then you have end-to-end tests, where even one test tests your end-to-end flow. You load your application, you load all the modules, you go through the web application and you click a lot of stuff, and that gives you a lot of coverage. And somewhere in the middle, there's integration tests, component, UI tests, and all kind of tests. And you have exactly the same thing. Sometimes it makes sense to write a unit test if you have something specific that you want to test, but it's like a small portion of your application. And sometimes you just want to write end-to-end tests. And the compromise here is which test will give you the most bang for your buck. Sometimes it's just like easy to write this kind of test. You know how to write it, you know how to maintain it, and it will give you a lot of coverage. So how would we test a project? Every project is different. If you find a test practice that works for one project, it does not necessarily mean that you can start working on another project and write the same kind of test. Let's take a look at the kind of like a diagram of or architecture of some application. You have a bunch of modules, some connections, relations, and you start your job on a new team. You work on a new project and you wrote some code and you want to test this module. So how do you test the module that you just wrote and you know nothing about the application? And there's tons of ways. You can test it in isolation, just require a file, call some function, and compare the output with, to something that you expect the module to return. You can test this in integration with other modules where you don't require your module directly, you require some other module that requires your module, and then you test through this. You can mock partially some things, or you can mock, for example, an API client or something and test the whole application without it. There's tons of ways. So the first I want to talk about is what makes a good test. So then I want to talk about testing strategies and what they are. And then once we find the test strategies, keep tests clean. And that's what kind of I call meaningful tests. So what makes a good test? There's a few things that are, there's a lot of things that make a good test, but the most important things to me are it should be fast. If your test is slow, it's probably going to be a problem. It's okay to run it locally if you work on a product, but if you work on a really big product and everyone commits slow tests and you change some code and it takes 2 hours to run the whole suite, you're probably just not going to run them, and you're going to commit a lot of broken tests to master, and it's just going to be a problem, especially with releases when you try to ship something fast and you have to wait for 2 hours for your CI to finish. Tests should not break often. If test breaks often, it's probably not because you broke the code, but because it's a really kind of like unit test that tests implementation. And the more tests break with no reason, the less trust you have in your test. So sometimes you just run your test, you see 15 broken tests, you're like, oh no, I broke my application, and then I can load it, it still works, and then you realize, oh, I didn't update mocks, or I changed the API signature and everything broke, but the application still works. Tests should be easy to read, understand. If you work on the team and you commit a test that only you can read, and someone else ships the feature and breaks this test, they're probably not going to spend time reading this test, they're going to delete it. And we don't want that either. And test, the most important, it has to catch bugs. A lot of times you have this kind of test where you work on some feature, you think this is great, you run your test, everything's green, ready to ship, you open your application, it doesn't load because, oh, the module is not found. And you're like, why? Probably because we have only unit tests and they test components in isolation, but you don't test the whole thing. And there's also a compromise between, like, do we want fast tests or slow tests that actually test things? And tests should have good coverage to effort ratio. It goes back to the chart where you want to find the kind of test that it's pretty easy to write, it's really fast, gives you a lot of coverage, and it's easy to write. Okay, so when we start writing tests for our application, we usually make a few iterations. You cannot possibly get the right test, right kind of template for your test because you don't really know. Sometimes you write a test and you think, wow, that's a good test. And then this test starts breaking on every change and you're like, well, I didn't think about this. And then you have to kind of like run it on CI for a couple of weeks and see how it performs. And once you found this test, you can say like, okay, this test is actually good, it works, we can continue with this. So interesting thing about this, every time I start on a new product, I try a lot of things. Most of them don't work, but then maybe in a couple of weeks, I'm like, okay, this is the way I want to write tests. But before I write a good test, there's usually a 2-week period. So now a lot of companies make those quality days, quality weeks, or hackathons, where you take a lot of people and say, hey, we're going to go to the room, and we're all going to write tests today. What happens is that we write a lot of bad tests. And that's a problem, because every engineer has to go through this cycle of this doesn't work, this doesn't work, this doesn't work, oh, that works. And because we usually don't share this information about which tests work and which don't, we end up with like 1,000 tests where like 700 of those tests are terrible, and we keep deleting them. And sometimes it happens so many times when we have those hackathons and quality weeks, and like a year later, I can't do it anymore. I'm just going to delete the whole thing and retest it because it's just, I spend more time fixing my tests than I spent writing code. So what can we do about it? Once we found this good test, we should share this strategy with everyone. And it usually takes, sometimes it takes a team of engineers that just do testing, and they test things, they build tools and infrastructure, and then once they found the good strategy, they can say, yeah, this is the way we should write tests. Other things don't really work. We tried it already. Use that one. So how can we do that? Test strategy. So this is an example from the project that I worked on. And this kind of like, I'll just take a counter app, which is, it has a button. Every time you click a button, it increments the counter. Pretty simple. So at Facebook, we use Flux, which is, I'm hoping everyone's familiar with it, but if not, I'll explain it a little bit. In the core, we have a UI. And UI does not have any business logic in it. UI just takes data store that we have somewhere, and it renders the data inside the store. And in our application, we look something like this. We have like a JavaScript object that has property counter and the number. And every time we want to render the counter, app would take this store, we'll put it in the UI, and it says, oh, it's a 0, I'll render 0. Now, when we click a button, we dispatch something that is called an action. An action is just some kind of like a function call. We can call it like that. And this function finds the mutation that is supposed to work in this case, and mutation is like, oh, I know how to increment counter. I'm going to go to the store, update the counter to 1, and then when the store updates, it takes it back to the UI, renders, and the counter increments. And then mutation is usually where your business logic lives. All the utilities, or kind of like data, massaging functions, everything is in the utilities. So general principles that we found in testing UI application. So UI is extremely hard. Every time you test plain JavaScript, it's pretty easy. You take the function, you call the function, you compare it with something that you expect. Once you add the UI, it's completely different. You probably have to have like a real browser or a DOM implementation like JS DOM. Everything that was synchronous becomes asynchronous. You have to do a lot of things, and it's really hard. Mocking too much reduces test quality. Every time you mock, you create something that is not real, and you have kind of like a fork. If you update real application, you have to update your mock, and sometimes your test can pass, but you have a bug, or vice versa. You don't have a bug, but your tests are red. And more isolation, less bugs caught. Again, you can have a perfectly, like you can have 100% coverage, a perfect test suite. It's all green. Then you load your application. Undefined is not a function. You don't want things like this. So based on those principles, we found this strategy where we have our Flux application. We take the UI, we throw it away. Flow and end-to-end tests are really good at catching bugs in the UI, because if you don't have business logic in there, you're kind of like, here's the data, and then like, if this data, render this. If you access some property, Flow will be like, I don't know the property. And it's pretty hard to have a bug in the UI, unless, well, it's still possible, but Flow is really good at it. So then we replace the UI with a test, and basically we write a test that pretends that we are a UI, and we're going to dispatch some action, and then that will go through the cycle, and then we'll get some data back, and we're like, did the data change? So in this case, we have a test. It will be like increment counter, and then you get some data from the stores, like, is it equal 1? Because that's what we expect. And that handles kind of like most of your application logic except the UI. So the test structure will be set up initial state. You create a store, then you dispatch an action, and you expect data to change. Pretty straightforward. This is how it looks in the code. You have test, increment, action. You have a store that you prepare. This is your first step, prepare, set up state. then you just do a sanity check that the counter initial is actually 0. Then you say dispatch action and expect the store counter to change 1. And this is actually looks like a scenario-based test because like it does exactly what it does. It says like I have a store, I increment counter, I expect the counter to be 1. And so the way we came up with a strategy is that we had an application. I started on the project. I wanted to test something. I go to my coworker. How do you test this? Oh, you open the application. You click the button. I'm like, write this down, put it in the code, make it look like just what he said. And that kind of worked. Push the wrong button. OK, so pros of this approach, failing tests, most likely a bug. We actually changed our whole Flux implementation from Flux to something else, and we recycled out tests. Because like the test, I increment counter, expect counter to be 1. It doesn't care about what kind of Flux library you use, Redux, Flux, or something else. It doesn't care about what utilities you use. It cares about, did the counter change? And that's what you're testing the actual product, that the logic that I have, the application, I click the button, the thing changed. Very easy to read. It's just a scenario. Survives major refactoring. Yeah, basically what I said. But yeah, if the test fails, it's got to be something with a logic. Like if counter is 0, like there's nothing to break. It only can like be false red if you rename the action or you rename or change the data structure that you have. What was there? Sorry. Anyway, it said it tests almost the entire app without the UI. So you kind of like have the whole cycle of all my code except the UI is tested by just the action. And that was really cool. So that's one of the strategies, not the only one, and it doesn't work for all application, but it worked for our case. So we found the strategy, and it worked really great. We kind of like dogfooded it for probably half a year, and then we're like, yeah, this is great. It survives refactoring, it tests, it catches bugs. We had some data to back it up that, yeah, those applications that use that test, they actually are more stable. So now that we found the strategy, how do we keep tests clean? There's a bunch of things that you can do here too. So you have shared test utilities, you have generation of test templates, LINT rules, and documentation. I'm going to talk about all of them. So test utilities. Sometimes when you write your test, you have some kind of crazy complicated setup logic. So maybe you have to like make initial request that sets up or gets initial data for your application. And sometimes you see tests where you open the test and there's a huge JSON blob right in the beginning. You write one test, you initialize the application, test something, then someone else is like, I need to write similar test, copy, paste, in another test, run it, then 15 more people come, do the same thing, then you change your API signature, the JSON is invalid, you have to go and test the whole thing and rewrite your JSON blob, and no one likes to read JSON blobs because they're usually 1,000 lines and you have no idea what's going on. So instead, you can create a function, mock initial data, and then you put the JSON, make it configurable if you want. You can add some parameters like 2 users, 3 users, the user of like that kind, the user of that kind. And then once you did this, you go to a team and say, hey, I wrote this thing. If you write a test, take my thing. If API changes, I change it in one place. Everything is just works after that. Really great example of testing of test utilities is ESLint. Who's not familiar with ESLint is a tool that checks your code and analyzes it and finds common anti-patterns. So for example, we have a code const a equals 1. It says you have missing semicolon. So ESLint supports those custom rules. You can kind of write a plugin that looks for a specific pattern and warns you about this pattern. So how would you test the rule? If you want to test the rule, you probably create a rule, I don't know, that looks for var instead of const. And if you use var, like, hey, no, you need to use const. And you probably create some code snippet, and you run the ESLint, and then you expect the warning to be there. But the whole configuration is pretty complicated, because you have to know how to run ESLint, how to provide your configuration, and it's kind of like tedious. And if you ask 10 engineers to test the ESLint rule, they're probably going to come up with 10 different solutions. So ESLint it ships with this thing called rule tester, and that looks like I have an object, and I have an array of valid code snippets, and it automatically expects that those should not have any warnings. And I have invalid snippets where I have some code, and this is the error that I'm supposed to get. And that's it. You don't have to connect anything. ESLint just comes with it. define your code and your errors, and it will run it. And I think it's really great, because once you create a lint rule, if you commit anything to your lint repo, they will actually require you to write rules. And here's the way we do it. You don't have to think about how to write tests. You just write them. Creating test templates. I wish I had a slide with an example, but that was the most successful thing that we ever came up with in testing. So if you write a test for a specific module, so if you create a test for a module that you want to test, and you just joined the team, you don't know anything about the application or how to write tests, you create a file that says, for example, in this lint, you're trying to create a rule. We can have a lint rule for a lint rule that says, hey, you have a lint rule, but you don't have a test for it. Do you want us to create it for us? And that can actually run a lint rule and create a test template for you and say, require, here's a configuration, here's your expect or something. And it doesn't actually need, you don't need to do anything. You just fill in the blank and it works for you. So for example, for Flux actions, we have them each in separate files. And if you open a Flux action, you'll have an ESLint, hey, this action should have test, and there's a fix button. You click the fix. It actually analyzes your code base, finds the stored parts that it modifies, and it inserts expects for this fields of the store, and then you pretty much just click fix. It has a test that is failing. You just fill in the blanks, and it passes. Once we introduce this rule, I think right now 20% of all our tests were written just because of this rule, which is crazy. Also, lint rules can have documentation in them. So for example, if you're trying to test something in the way that we know doesn't work, and we have a utility library to help you with that, you can search for it and say, I noticed that you have this test, and you test a module of type X, and you're not using X test utilities. Here's the link for documentation to read more about. And it can say yeah, we tried other approaches, and they didn't work because of that and that and that. You should use this. And this is great because you're not pushed documentation when you start on your team on the first day, and here's a gigabyte of documentation that you need to read by tomorrow. No, it's more I start writing tests, I do something wrong, here's the documentation. It's relevant to me right now, I can read it. So after you find all those test strategy, what happens is that usually in JavaScript or anywhere, we separate tests by end-to-end integration and unit, which is no one knows what's integration test. Everyone calls everything with integration. That is not unit. Once we define the strategy, we take those and we split them in actually different groups of tests. UI component tests, data mutation tests, app routing tests, anything. And we kind of make more categories. And for each types of tests, we know exactly how to write them instead of just having abstract, we need to write more integration tests. No, we need to test our components. And if you work on a team that provides component library for a company, you know exactly what it is. You wrote a calendar, you want to write a test for a calendar. Or if you work on GraphQL API, you know that you need to test your endpoints. And there should be a way of testing your endpoints with a specific utility library. And that should never be a question. And at the end, I just want to say that it happened before. So for example, 10 years ago when I tried to get a job as a web developer, every interview people were asking me about SQL and how to write an index for a database. And I'm I just want to build buttons and paint them blue with CSS. And no, you have to index your database. And that was kind of annoying, and a lot of people were annoyed, why do I have to know all of that when I just, I'm a web dev? And then we kind of have we started having those database services, especially in the big companies. They're usually a team of 20 people. They provide you 2 APIs, get data and set data, and you just focus on what you like. You write websites, and the database oh, this query is super slow. We're going to optimize it because we know how. And you're do your stuff. Same thing was plain JavaScript applications, single-page application, maybe 5-7 years ago. Every single application started from the same thing. What kind of architecture we're going to use? MVC, MVVM, different kind of stuff. There's so many of them. And someone's oh, we're going to use MVC. Next month, you have 15 implementations of your model, 20 implementations of your controller, and it's just complete chaos. And then JavaScript frameworks came where it's Backbone, inherit from our model, you just use it everywhere. And it was oh, cool, I don't have to think about architecture. I can write code and ship features instead. And at the end, when React came out, I think every application, when you start, it was the same conversation. Webpack or Browserify, are we going to use that or that? And like, how do we configure things? And then Create React App came out. It was like, that works, do that. And I think we can do the same with testing, where if we define more patterns and more categories, we can say, hey, you like writing UI elements, just write them. If you want to test, here's how you write tests, and don't worry about all the different like unit integration tests. We got it. Just generate them and fill in the blanks. Yeah, that was it. Thank you.
Thanks so much, Aaron. We did write a lot of code together, didn't we? Good. That was really good fun. So this was probably the least Jest talk of today. Except for our final talk. So yeah, I hope that this was a lot of good information how you can write better tests, meaningful tests, so you can actually build better products. So now it's time to actually hear about a bunch of really cool new things that are gonna come out in the new Jest release that is gonna come out in the next few days or so. So Rick, maybe you can give us an overview of that. Yeah. Thank you so much.
Definitely. Hi, everybody. I'm Rick Hanlon. I'm from Akron, Ohio, home of LeBron James. I work as the engineering manager at a company called Customer in New York City, and I'm on the Jest core team. Blazing fast. So you may have seen this tweet from Andrew Clark, who gives a really great tip that if you're evaluating a library for how fast it is and it doesn't say blazing in the README anywhere, then it's not fast, because blazing means good. And keep that in mind throughout this entire talk, because this is the common theme for snapshot testing in Jest 23. Who here has used snapshot testing before? Wonderful. This is going to go really well. If nobody raised their hands, then this would bomb. Jest 23, I pulled up the diff here on GitHub to show you it didn't load, but this should be the diff between 22.4.4 and master, so let's just reload a couple times. Okay, great. That took a while, and the reason that it took so long, don't mind the build failure. The reason that it took so long is that there were over 200 commits, 500 files changes, and 106 contributors. We have a really great community around Jest. Matt's going to talk more about the community later. But thank you to everybody who is either active in the issue repo, filing bugs, asking questions that we close immediately because it's not a help center. But Jest 23 has a lot of great features, and also shares the number with LeBron James. Did you know he's from Akron, Ohio? The features that we're going to go over today for snapshot testing in Jest 23 are the new, better snapshot summaries, the interactive snapshot mode, which was technically released as a minor in 22, but we improved it for the 23 release, and a new feature that I'm very excited about that we're calling snapshot property matchers. First up are the better snapshot summaries. So since everybody in the room has used snapshots before, you're familiar with the snapshot summaries that we have in place today. You'll notice that for the tests that are in, we have 2 snapshots written, 2 failed, and 10 obsolete. And if we will go and dive into this output, you'll see that the written snapshots and the failed snapshots both specify how many suites that number of failures or writes span across. But for obsolete, you're out of luck. For the written test, the summary says that there were 2 added, so there's some inconsistency in the language there. And my personal pet peeve is that both the failed snapshots and the obsolete snapshots are both red, which are indicating failures. And can't very quickly identify what the issue is. Finally, you'll notice that the obsolete snapshots are not even represented in the summary at the bottoms. They're just kind of hanging out there in red up at the top. But remember, blazing means good. So in Jest 23, we have this new updated snapshot summary. So you can see that every different status has a different color. Green means that they were written, red's failed, yellow means that they're obsolete, and you will probably want to remove them, but maybe not necessarily. Down at the bottom, you can see that all of the statuses are represented, and the language is consistent between all of the statuses. All of the test suites match up, so you can see how many suites or files have the different status updates. And the feature that was requested a lot was to actually specify the obsolete snapshot files, as well as the actual test names that are obsolete, so you know what you're going to remove when you hit update. So now when you hit update, in Jest 22, you would get this snapshot summary, and you can see that 10 obsolete snapshots were removed, and it's in red, which to me indicates a failure. But nothing failed. It worked as expected. That's what you wanted to do. That's why you hit U, because the instructions told you if you hit U, you'll remove them. So in Jest 23, it's blazing green. That's the actual color in my terminal. And that just lets you know, hey, everything's going good. You said update, we updated it. So there you go. You see that the updated snapshots and the removed snapshots are all at the bottom. If anybody is paying really close attention, you'll notice that there are 10 removed, 2 updated, 4 passed, 6 total. And in a previous slide, that number count was wrong. So pull requests are accepted. And that's the new snapshot summaries. Next up, we're going to cover a feature that I'm really excited about. I think that it's going to allow people to go much faster and have better snapshot testing practices, and that is interactive snapshot mode. So we're going to start with a passing test suite that has 10 snapshots in it, and those are passing. We're going to write some code. Thank you, Tom Hanks, for your assistance. And after we write that code, we're going to have those 10 snapshots failing. You can see the snapshots failing down at the bottom. You're probably used to kind of scrolling back up through that history, looking at each one individually, losing your place. And if everybody in this room is honest, you probably just hit update and test pass. All right. That's not great. You should be going through those snapshot updates individually one by one and actually verifying that the old output and the new output makes sense based on the code that you updated. But remember, blazing means good. So in Jest 23, we're going to start with the same number of tests. We're going to also have Tom Hanks code for us, and we're going to have the same number of failed tests. But now we have an option in the watch mode menu to press I to update the failing snapshots interactively. What this is going to allow us to do is step through each individual snapshot throughout each individual file and decide if we want to update that snapshot or skip that snapshot and not update it. So we'll go ahead and do that. We'll go into the interactive mode. Down at the bottom, you can see we're now looking at one failed snapshot from one suite. We can see the suite that we're in, the tests that were focused that failed, the 4 that are currently skipped as we're stepping through them, the failure diff. And down at the bottom, we have a progress for the interactive mode. Remember, we had 10 snapshots failing. And it gives us the option to either update or skip or quit and find a new occupation. Let's go ahead and update Snapshot, and you can see down at the bottom the interactive progress. One updated. We'll skip the next one, skip a few more, update a couple, and as we go, we're just kind of given an opportunity to really inspect and look at the changes that we're making, rather than just hitting U. And anything we can do to not just mash U and then hope that somebody actually reviews our snapshots on a pull request will help us move faster, write better code, and have more confidence. Once we've gone through all 10 of the snapshots, we'll get a snapshot result, and you can see of the 10 snapshots that were reviewed, 7 updated, 3 skipped. Now we will restart, and when you restart, you can see that there's 3 snapshots remaining. We can go ahead and update those 3, and now we're done. And that's the interactive snapshot mode in Jest. The final feature that I want to talk about is a feature that we're calling snapshot property matchers. So for this case, we're going to actually have to look at the code. We're going to have just a really basic test with a user object. The user object is going to have an ID that's randomly generated. This might be like a Mongo ID, auto-incrementing ID in a SQL database, and a created at. That is going to be a new date every time the user is created. We're going to snapshot that user, and we're going to run the tests, and that snapshot is written to the snapshot file, which is great. On the right, you can see what the snapshot file looks like, and you can see the date and the ID that we wrote to the file. Since everybody in here has done snapshot testing before, you know what the problem is. When you run the test again, new date is generated, new ID is generated, the snapshot fails. It fails because the date and the ID are different. And it doesn't matter how many times you run it, they're going to be different pretty much any time. And that's because the ID and date just don't match up. And we have 2 options for dealing with this. Option 1, let's just monkey patch the JavaScript globals for the functions that we're using. All right, great. The floor function and the date function, those are now just going to return snapshot values. This is a terrible strategy. You should not do this, but it does work, and it is something that is very common to do, and we see it in the issue tracker pretty frequently asking how to do it. Of course, if you do that, the test will pass, and hopefully somebody calls it out on a pull request. Option 2, we can just reassign those values on the user and just not print them into the snapshot at all, and that will work. Option Jest 23, blazing means good, is a new syntax for to-match snapshot. So to-match snapshot will now accept a object that has property matchers that are asymmetric matchers that will then get written with the asymmetric matcher syntax to the snapshot so that when you run it, the test will pass. This is very similar to option 2 before, with one very key difference. And that difference is that if the data changes types in the user object, so we'll switch the ID to some ID, and we'll switch created at from new date to date.now. Date.now returns a number, created at returns a date object. Then our type no longer matches. And so when you run these tests, the test will fail because the snapshot properties for the object no longer match the property matchers that were passed into the snapshot. So we're writing to the snapshot the stringified value of the asymmetric matcher, but we're also running those matchers to make sure that the data type doesn't change. So you still have confidence that created at is a date, but you don't need to actually care what the date is. and that is the snapshot property matchers in Jest 23. All of that and more is available today. We just pushed the release during the intro, and so take a look, let us know how it is. If there's any issues, file an issue. If you have any help questions, Stack Overflow is a great place for that. But let us know what you think, and if you have any suggestions, reach out to us. We have a Discord channel in Reactiflex that we'd love to talk to you in.
That's awesome. You guys, I had no idea this was going to happen. This is great. Are you having a good time so far? Yeah. So this is like a feature that I think is really going to change how we do snapshot testing, and there's like a lot of stuff that we can build in the future there that's going to be even more awesome. I think the like long-term goal and vision for snapshot testing is always that you actually don't have a snapshot file. You just write your assertion and you just plug it right in there, and like you just update the file. Back when we built snapshot testing, things like Prettier didn't exist. So pretty printing like a test file that you update with a tool all the time wouldn't have worked. But maybe in the future we can actually make it so that snapshots are inline in your test, and we just kill all those files. We haven't worked on that yet, but if that's something that excites you, please get in touch with us. And I just want to say, like, these are the kind of things where the Open Collective is supposed to just really support external folks, people who do not work at Facebook, that build these amazing features that we are not even thinking about. So this is really awesome. So thanks so much for doing that talk. Jest 23 is out now, so you can, we'll have a 10-minute break, so you can choose to either go update your yarn dependencies, push a new release of your thing, or we can have a good chat about testing JavaScript and whatever else we're doing. And then after that, we'll have a bunch of cool lightning talks. So thanks so much for now. Hey. Do you mind if we continue with a bunch more talks? I know that you're probably all having a lot of fun over there. We will have some more time later to chat. So I really, I appreciate that you guys are all coming and listening to us about what we have to say about Jest and JavaScript testing. So before we get started with the next talk, I just want to, give a little bit of an introduction of what Simen is gonna talk about. So one thing that I mentioned earlier is usability, right? And it's really important to get these things absolutely right. And a lot of you in there are front-end engineers. Maybe can you give me a show of hands who considers themselves a front-end engineer, like just primarily working on UI stuff? That's a lot of you, right? Like about half or more. So that if you're building a test framework and you have to everything, all your tests are passing, it doesn't really matter what's being printed. Jest is probably a bit more verbose than it needs to be. It tells you everything passes. And the thing is, maybe that makes you feel good because before they were all failing and it's all red, but then you fix your tests and then it prints you this entire row of past tests, and it's like, oh my God, that feels good, right? And these are things that you don't see in metrics, right? That you don't see that in how many people are using Jest or whatever. These are things that emotions and feelings that these kind of tools or products are giving you. And for error messages, I think that is even way more important, because when your tests are passing, it doesn't really matter what is being printed, but when your tests are failing, there's this question about how can you present errors in the most useful way. How can you get the most signal out of this error message so that you can quickly go back to the code and figure out how to fix your thing. As front-end engineers, this is also something that we look for when we hire front-end engineers here to Facebook. There's this level of craft, this attention to detail. We're not just building some product or whatever. We're actually building a product and trying to figure out how to build the most delightful, the most awesome user experience. Thinking about how that thing makes me feel when I'm using it and all that kind of stuff. So Simen is going to talk a little bit about how Jest, how we think about that in Jest, and like is going to give a bunch of examples. So thank you so much.
Yeah. Yeah. Hello. I don't really have slides, so I was just gonna show something else, but the internet is gone, so yeah. This is GitHub though, not us. So yeah, my name is Simen, and that name doesn't really work in any English-speaking countries. So I try to roll with Simon or Simen, but not the Norwegian one. So why I really like Jest is, Christoph just said it actually, it's mostly the error messages. I like that they are short, concise, and they have a good diff. Like, my test failed, cool, but why did it fail? With colors and some emojis and stuff like that makes me happy. So my contribution to Jest is mostly closing down issues and fixing stuff like, if it works, yeah. That's my contribution of the day. So, but other than that, I try to fix our error messages. So I don't have a talk, so my follow-up to Rick is pretty low-key. But I'm going to show examples from Jest 21 and Jest 22 and Jest 23 and how it has improved. So I don't remember the name, so I have 8 tests prepared, and I'm just going to start with the first one. So this is Jest 21. It says 21 right there. With a basic assertion error, which is nice. And in Jest 22, we added a code frame. So like, this is where it failed, which makes it a tiny bit easier, at least to like figure this is the assertion and it's fixed. And that is not very much more interesting in Jest 23. We've added another small arrow right there. But that is pretty much the same thing. But all the other ones. So if I do, what was it called? It's called async2. An asynchronous failure. I can actually show you the file. Let me do that. Async2. That's the file. That's my test file. So it's basically, you expect some promise to resolve to something, but it rejects. And in Jest 22, it's the same thing. We just removed some of the tick callback and generator throw, but it's basically the same thing. But now in Jest 23, we can actually tell you this expect is the one that's failing. So now we're able to keep the stack trace even across asynchronous boundaries. Let's see. I have more async tests. What's the other one? Yeah, so this is basically the same thing, only it actually resolves, but the assertion is wrong. Here is foo, here's boss. So async. It'll probably run both. Yeah. So Jest 21 gives you the diff, which is nice. Jest 22 also gives you the diff, but with less stack trace you don't care about. And Jest 23 gives you, it points back to like, oh, that was small. Like this 2 equals is the one that's failing. So again, we're able to keep the stack trace. Let's see, timeout. So this is a test that's going to time out, since we set timer to 50 milliseconds and we don't call done until it's been 75. Timeout, whatever. And it times out. Pretty much the same thing in Jest 22. It times out, but with less stack trace you don't care about. And in Jest 23, we get a stack trace. This test it's timing out. Yeah. Some of my... I was really happy when this landed in Jest, which is basically if this test has no assertions, then it should throw, which pretty much means you have a try-catch and the catch didn't hit. And you can also say it should be at least 2. So, yeah, should have 1, it wasn't. Should have 2, there was only 1. In Jest 23, 2? Yeah, 2. It's basically the same thing, but yeah, the common theme is we just removed some stuff from the stack trace, which is interesting. But in timer, no, sort. Just 23, as is the common theme, we now pointed here is the place you call has assertions, and here is the place you call assertions. So that's why it's failing. What number was that? 4. Oh. That one. A very common error people got was when we changed from, if you call done with anything, that means you failed the test, instead of just done.fail. So people having like promise.then and just pass done without explicitly calling itself, they suddenly test started failing with this is the thing you call done with. And there were quite a bit of issues about that. I can't write done. Yeah, done. Yeah. So we got this failed object at stack formatter. Very useful. And yeah, the last one you didn't see. What's the file called? Non-error done. Okay. Non-error done. So this is just 22. Same thing, only with less stack trace, as per usual. I can actually just do that. No, I couldn't. Non-error done. Oh, let's do it up there. Ooh, colors. Now in just 23, we actually like print the object. This failed. And then something. Yeah. Non-error. Oh, I should show you the test first. 05. That one. So this is just you return a rejecting promise. Looks like that. Pretty much the same thing. Failed object. Can I do this? No? Okay. Just 22. Pretty much the same thing. Less stack. And as is the common theme, in just 23, we get the same error. And a pointer to your code, since we now support asynchronous stack traces. So that was number 6. It's just you throw something that's not an error. Like the answer to everything or just nothing. What's that? I forget the file name already. Random. Just useful enough, I suppose. I can't write. Just 22, the same thing, but with less stack trace. But here we actually have a stack trace, which is cool. When you throw a number, you don't get a stack trace. In just 23, we say this through 42, this is the test, because we have no idea where you actually threw. That's impossible for us to know. But we can actually say this is the test. And the same with undefined. And we actually also say thrown undefined, instead of just error. We say throw undefined. Yeah, those are the new stack traces. I hope they will help you track down your failing test easier. But I've also got 2 other things I want to show. The first one I'm really happy about, which is I have a test which is something should be true, but it requires a server. And this server looks like, not like that. It looks like this. So we just create a server, right? And if you run, what's the file called? Server. If you run that test in Jest21, it passes, because the true is true, but the test is just hanging, right? So you can pass force exit to actually quit. Fixed, right? In Jest22, it's the same thing, just hangs. But in Jest23, we hanging. It hangs, but it then prints an error, like, hey guys, I can probably, yeah. It didn't quit after 1 second. Have you tried this new flag? And I say, no. I'm going to force exit you. But then it still says, oh man, come on, please, try this new flag. And I say, okay. Seems to ask so nicely. And then we say, that's the reason your test is hanging. Right there, you're listening to something. So I hear Facebook already wants to suppress the message. But yeah, hopefully you use it to track it down instead. And I've got one last, which is, I can show the file first. So this is a test which it's not asynchronous, but we set it's asynchronous in practice, right? Because we do set timeout 0, so the event loop ticks and the test exits. And then you require something and expect 5 to be 5, right? By calling a function called double, which naturally returns the same thing you give it. Double is implemented as actually like doubling the number. So in Jest21, if you require it, the test pass and an exit. Cool. Even though, yeah, 5 plus 5 isn't 5. But Jest doesn't care. It just exits. Since your test was done, right? In Jest22, people got a bit mad about it. But we actually give you an error, which is this really nice one. Cannot read property object anonymous of null. But it passed. Pretty sweet. Yeah. A lot of people got this error, and Christoph was like, yeah, you're going to get a more enclosed issue. So let's see if we can improve on that. So in Jest23, it says, I mean, it still passes because the test has completed. We have no idea of like going back and say, hey, by the way, this actually failed after we said it passed. But we can tell you that, hey, you're trying to import something after the Jest has been torn down. This is your import. Please fix it. And yeah, that's it.
Thank you so much. You see how there's, like just a little carrot here, or like a little bit of green, or a little bit of red here, or just actually printing out the line instead of completely failing. Like there's all these like tiny little things where it looks like almost indistinguishable. This is a very hard word for me to say. Sorry. If you compare them across versions, but then once you get used to it, it just helps you so much, save a few seconds here or a few minutes here when you're like debugging something. So that is awesome, and a lot of work goes into that. So thanks for both working on all of that so hard and presenting it today. So the next talk is going to be more about all the things outside of Jest that you can use to just turbocharge your testing experience. And Matt is going to walk you through that. Thank you so much.
Cheers. Hey, I'm Matt Phillips. I'm based here in London, and I'm one of the newer contributors to Jest on the team. I've published several open source packages in the community around Jest, and today I'm going to touch on them and how we can refactor your code to actually level up your experience. So if we start off by looking at some code,
We've got some pretty basic tests here, doing some pretty gnarly looking assertions. We've got a simple test just looking at a string and asserting different properties on the string. We have another test that looks at a Fibonacci series, an array of numbers, and makes different expectations on that array. And then finally, we're going to look at a test suite that looks at an add function and makes different tests against that function with different data. So if we look at these tests, the bit that annoys me the most, and hopefully you feel the same, is the left-hand side of the expectation. So expect something to be something else. We have to do a lot of work just to be able to make an assertion. So I'm sure most of you have used chai, the assertion library in JavaScript, and looked at this and thought, why can't I just say expect something to be something, and it's done. You can be a lazy developer like me and not have to do any work. Unfortunately, that doesn't exist, or does it? So if we look to the community, we find that we have Jest extended. So Jest extended builds on top of Jest expectation library and brings in chai assertions to Jest. The key distinction with that is the error messages, as Simen's just touched upon. We're able to still get the benefits of the delightful error messages, but write more declarative tests. So if we go back to our code that we were just looking at, we see that we're normalizing a string to be lowercase to make an equality check on it. We're trying to maybe assert on the start of the string by splitting, and then the end by doing the same. And we've got like this funky reduce where we're trying to count the number of lowercase l's inside of our hello world. A lot of heavy lifting here just to make some basic assertions. So instead, with Jest extended, we can just write these tests very declaratively, and we don't have to do much. We're able to just use the matchers that are available to us in Jest extended. So that gnarly looking one on line 7 can now be written with to include repeated L 2 times. If we look at our Fibonacci tests, again, we're doing all sorts of like weird things just to assert different properties on our array. And coincidentally, on line 7 again, we've got this assertion whereby you would think, or at least I thought, that I could say to contained and pass in var args with multiple arguments to the matcher. But actually, line 7 passes and doesn't fail, even though it's got like 10 million or whatever that number is in there. It just looks at the very first item. So if we refactor our code with Jest extended, we're able to reduce the number of assertions we're actually writing, and we will get more declarative error messages out. So an example of that would possibly be the array.every. We're actually boiling that down to just Boolean logic. So we're just going to get false, expected false to be true. But within Jest extended, if there was a named function there, we could actually say that your array didn't satisfy all function name. So it's getting there. It's getting better. We've been able to refactor our code. We've got less noise, less verbosity, and more explicit tests. But there's still part of this that bugs me. So the perfectionist in me looks at that and says, why am I having to say expect string multiple times? Like, what's that, 5 times? Or expect array 5 times. Why can I not just write that test like this? So expect array to satisfy all, to include all members. So we go ahead and run that test. We give it a go, npm test, and we get a failure message. And the reason is it cannot read property to satisfy all of undefined. And that's because Jest expect is a void. It doesn't return anything. So we're unable to chain our matches together to be able to make these declarative, powerful assertions. So again, if we look out into the community, we find something called Jest chain. This allows us to chain core and custom Jest matches together to make declarative assertions whilst writing less code in the process. So if we take a look now, our tests have gone from having to jump through loads of hoops to make our expectations and duplicating the same characters over. We can just write our tests like this. And you could maybe argue now you only have one assertion instead of multiple assertions. So if we think back to our code at the start, we also had a test suite of an add function with multiple tests on that test suite. And again, this bugs me. If you find yourself copying and pasting tests or duplicating tests, there's a solution to that problem, and it's called parameterized testing, which we have a solution for with Jest each. Jest each is a parameterized testing library for Jest, which supports data tables, and it allows us to write our test once and supply data to be ran over that test multiple times. So if we look at our test suite, it's the exact same as just before, but we can now refactor that to be one describe with one test and multiple rows of data. So each is taking an array of arrays, a table of rows and columns, and for each row, it will run our test and pass each column into the callback of our test function. So instead of having all of that duplication, we're able to reduce it right down to like 9 lines of code. And if you're feeling adventurous, you can try out the data table syntax, whereby you are able to supply column headers and give rows of data in a tag template literal. And again, this invokes your test with the object. A quick side note on Jest each is that it's actually just been released as part of Jest 23 today. And Prettier does support the data tables, so you won't have to format them yourself, thanks to the guys on Prettier. They were amazing, and yeah, did that very quickly. It will be available under test.each and describe.each and the various aliases on those. And for the sorry few out there that can't upgrade, Jest each is still available, so, and I'll be maintaining that still. Just want to make a quick note about the Jest community as a whole. So the core contributors of Jest have created an organization on GitHub called Jest Community, where they maintain multiple packages that I'm sure you've all used, like ESLint plugin Jest or VS Code Jest, Jest Extended. Definitely should check that out. And yeah, I recommend just getting involved with it. Like, don't be shy. We are, I suppose. I'm part of it now. We're welcoming people, and yeah, like send pull requests if there's something you think can be done better, like error messages in different versions of Jest, then definitely speak up and get involved. And a quick note on Awesome Jest, that is a awesome list of packages that we all recommend, and like learning resources if you just want to get into testing. So definitely something to check out as like a go-to when you're looking to integrate with Jest. Thanks.
Thank you so much, Matt, and thank you for all those contributions you have already made to Jest in such a short amount of time. That's great. So I'm really just like sitting at my computer trying to listen in and like tweeting about all these features, and I just cannot keep up. It's ridiculous, like how much work went into Jest 23 and how many new awesome things there are. So before we get started with the next talk, I want to actually give a hug to Michele. Hey. So Michele is actually the person who set all of this up, who made this event happen. Thank you so much. But also the folks there in the back who just provide this amazing setup with like, it just works so perfectly. Thank you so much. I love it. I don't know, we should do more of these events. All right, so Michele has been at Facebook for about a year and a half now, right?
Yes.
Wow, it's been a long time. Yeah.
Yes.
And since he joined, like he actually joined the company after he wrote a book about React design patterns. And the interesting thing there was that it had a chapter on Jest, and we had like a release of like whatever 19 or version 19 or 18, whatever it was, a major. And like 2 weeks later, that book like came out, and it had like the latest like error messages from that version in it. I don't know how that works. Like moves really fast. But yeah, ever since Michele like joined Facebook, both internally at Facebook and externally at like various conferences that you might have been to, even here in London or in Amsterdam or Italy, right? Like all over Europe, really. Michele has been a great supporter of the Jest project. So today is going to talk a little bit more about snapshot testing. All right.
Thank you. Yeah, thanks to Christoph. Like this was like really cool introduction. So yeah, I don't need to say this. So I'm Michele. I work upstairs. I build user interfaces. As you can tell, I'm not a heavily Jest contributor, but I have 4 commits, mostly documentation and a couple of fixes. But yeah, I'm going to talk about what I built using Jest, just to show you how the great API that Jest provides lets you build like something cool on top of it. And the first thing I'm going to talk about is Jest style components. How many of you know what style components are? Yeah, not everyone, but yeah, it's a way to create style React components. So you generate a component, for example, a button using the style function. This is going to render a button element in the UI, but also you can define the style that this button is going to have. And this button is going to have the color red. And when you want to test it, you import React, the renderer, you create the tree, and you expect the tree to match the snapshot. And this is going to be the snapshot. This snapshot is going to contain the class name. And first of all, you didn't add any class name. Style components did. So it's just weird seeing the class name there. And also, the class name changes all the time. We've seen the same problem is now fixed in Jest 23. I didn't have time to update this library, but I will do it later. But actually, we have a biggest issue, so I'm going to show you what is the issue. The first issue is actually very similar to the one that the Jest object matchers are going to solve. So basically, if you change the color of this button, Jest, and you run the test again, Jest is going to tell you that the class name is changed, which is not entirely wrong, because you can assume that if the class name is changes, the style is also changed. And that's pretty cool. That's how the snapshot provides value to your workflow. However, it doesn't tell you what actually changed, because you didn't change any class name. So a way to solve it is to just import Jest style components, and this is going to do something magic for you. So when you install it, you run the test again, and Jest is going to complain, because it's going to say, hey, wait, there are a couple of things that have changed. First of all, you're going to have the style as well in the snapshot. So the style is there. So you have the information inside the snapshot. And secondly, it's going to put a placeholder instead of the hashed class name, so that every time just style components recalculate your style and change the hash of the class name, it's not going to make your output very, very noisy. And in the end, your snapshot is going to look like this. You have C0, which is just a placeholder, and the actual color of the button and the button itself. So now, if we change the color of the button again to blue this time, Jest can really tell you what changed. So you really know why the snapshot is failing, and just a line that is failing. So you don't care that the class name is changed, because that's an implementation detail. And this is the first one. And this is possible only because Jest provides this add snapshot serializer API that lets you create, add any serializer that you want, like one or more. And basically, it's a hook in the serialization pipeline where you receive the object from the expect function, and you can do something about it, mutate it or do whatever you want before the file is written. And this is how this library has been built. And I really encourage, because Jest is great, it provides great default, but sometimes it doesn't solve your problem because it cannot solve all the problems. So I really encourage you to try and build your own stuff just to make testing even more delightful. And since I published this package, different packages has been built, like in the similar fashion for other CSS and JS libraries. So you don't only have just packages for style components. You also have Glamour, Hello Kent, Emotion, and Linearia, and many more, I think, that I don't know about. The second project I want to talk about is SnapGuidist. How many of you know about React Style Guidist? There's not that many. How many of you know about Storybook? OK, React Style Guidist basically solves the same problem. So it lets you create a component library. But Storybooks, you have to write stories, while with the React Style Guidist, you define all your components in the different states using a README. But the logic and the problem that they're trying to solve is very similar. And SnapGuidist adds snapshot functionalities to Style Guidist. And the way you use it, you just wrap the StyleGuidist configuration into the SnapGuidist function, and that's it. And the magic is going to happen. But this is better if I show you a quick demo. So this is how React Style Guidist looks like. You have like the name of the component and the path, and all the rendered version with the different props. So for example, a button with Hello React and a button with Hello Santa Claus, just because, yeah, I built this demo like it was Christmas. And but yeah, just to have different like properties, you know. And if you are familiar with React Style Guidist, for the few of you that are familiar, you notice that there is a green line here. And the green line means that there is a snapshot for this component, and the snapshot matches the current code. But React Style Guidist is also a playground where you can play around with the code and change it on the fly. So if we change, for example, this Hello React from Hello React to Hello Jest, the green line is going to become red. And why is it red? Because if we check the current snapshot, the snapshot says Hello React, while the UI has Hello Jest. So the line is red because the snapshot doesn't match. You can also expand it and see what's changed. So basically, you have the same experience that Jest provides. And you can update the snapshot from here. And this actually updates the file, so you can commit it. And basically, you didn't write any test. You just have your component library, and all the components are tested. And this is thanks to the fact that the way Jest is structured, because Jest is built on top of like smaller packages, and you can actually cherry pick these packages and just use the ones that you really need. For example, to build the SnapGuidist, I use Jest diff and Jest snapshot, and that's it. I didn't bring all the whole Jest package into my package as well. And if this is interesting for you, I really encourage you to check out a talk from Rogelio, which is also a contributor of Jest, and he's talking about Jest as a platform, so where you can actually really cherry pick different part of Jest. For example, you can use the Jest runner to run ESLint. That's an example that he has in his talk. And if you are into Storybook instead of React Style Guidist, there is story shots, which basically provides the same snapshot functionality. So my takeaway here is that like Jest is great. You can make it even greater, like just by using these APIs that Jest provide and all the packages that it offers. And thank you very much.
That was awesome. Thank you. So that's it about Jest for today. I hope that for all of you it was worthwhile to come here, because we're all having like family, or we just want to hang out, relax, watch The Expanse. Hopefully, safety Expanse. Yeah, hell yeah. Anybody who is watching The Expanse? That's the most important poll. Okay, so everybody is going home after this. Turn on Netflix. Check out The Expanse, best sci-fi series that's on right now. Read the books. The books are really outstanding too. I woke up at 4 a.m. This morning to watch it. I'm a little bit. I'm here for the entertainment too, So anyway, so I hope that this was worthwhile, because everybody has a lot going on in their lives, and we're taking time out of your calendar to talk to you, right? Like, and we don't even know you, and you come here for us. So thank you so much for that. I really, really appreciate that. Especially, and I've talked to a bunch of you earlier, that a few years ago, Jest was really not in a really great state. It's been out, like it has existed for like 5 years already in open source, and 7 years or so at Facebook. And we didn't really maintain it well. And then we got a bit more serious about testing. And it was just, it didn't have a community built around it. So the fact that there's like this entire first row of people that some of them work at Facebook, some of them come from other places all over the world, to hang out together, to announce these amazing features, to build these amazing features, that really means a lot to me. So thank you so much for everyone for coming. Thank you. I'm getting a bit emotional here. So the last talk is going to be by Jordan, and I encourage you to just, forget everything we've talked about earlier. To remember that tomorrow when you go back to work. But now just sit back and relax and enjoy this last lightning talk. All right, let's give it a go.
So yeah, as the slide says, I'm Jordan, and I work at Facebook in Menlo Park campus in California, and I work on the Nuclide team, which is our internal IDE. But this is not about that. My computer has fallen asleep. Okay. But yeah, this is not about that. This is about actually a side project that I worked on, and which I thought might amuse some of you, and some takeaways that I had from working on that project. So the project's called Webamp, and what is it? So it's Winamp, which for those of you who are maybe too young to remember, was sort of the canonical MP3 player from the late 90s, sort of Napster era. But this time it's been re-implemented in JavaScript. So I'll give you just a quick idea of what it can do. Let's see, we get a little bigger here. Winamp does have this convenient double-size mode, but it never supported it in the playlist. So you can play your audio. Let's see, we got some audio here.
Whips the llama's ass.
You got your visualizer. You can drag in some sweet jams from your file system. Got a couple different kinds of visualizers here. Probably this, maybe. Yeah. So you get the basic idea. But what I wanted to talk about was sort of what I learned by this process of imitating someone else's application, and sort of using that as a tool to learn. Because when I started this project, I actually had never really written any serious JavaScript. I had written sort of stitched together bad jQuery plugins, and it was this project that I think taught me JavaScript and taught me a lot of other things as well. So I think this process of imitation can really help you to understand deeply the thing that you are imitating in a way that no amount of just sort of direct study can. So I think it really helped me to understand what makes great UI and what goes into making great UI. So if we go back to this example here, you can see we've got this volume control, and you can change it and you get this sort of spatial feedback. But there's also this element, I forgot to show my slide, of inferring user intent. I'm going to switch back here. So one of the things that I think that I really figured out from studying this application is that there are times when the user is trying to show your program something, and if you can go the extra mile and meet them there and infer what they intended to do rather than just sort of what they actually did, you can provide a much better user experience, even if it takes a significant additional engineering effort. So I'm actually going to, the volume thing was actually from the next slide. So I'm going to step back. So you could rearrange windows in a Webamp or in Winamp. But often what you really wanted to do was to just sort of organize the windows into sort of a cohesive unit. And so what it will do is it has this snapping. So as you move it close to the right place, it will snap into position. And this is just one example of a place where if you left that up to the user to have to do it manually, it would be extremely painful and it would feel really awkward the entire time. But because they've taken the extra effort to build in all those extra algorithms, it feels really nice. In another example, a tiny example here, which I don't think I really noticed when I was a user of the application, but if you change the balance, you can change the balance here. But usually you probably want it in the center. And it would probably be really frustrating if you were constantly stuck at like 1% to the left. And so when you get close, it just snaps it to the center. So this is like a really cool instance of inferring user intent. Another one is just the different ways of giving visual feedback and how important that is to delivering a great UI. I guess I should caveat here that not everyone considers this a great UI, especially in 2018, but I think at the time it was much beloved. So I was talking earlier about this volume control and that you can sort of control it. You see this sort of spatial feedback, but you also notice that the background is changing. And so that's like another way that they're going out of their way to show you, to give you feedback. And then you also notice up here in this little marquee tag that it's giving you the actual number of your volume. And so they've actually gotten 3 different ways to show you the value that you're setting here and to give you that feedback. And I think that's really cool. And over here, we have these sliders again. And again, you've got the spatial and the color, but they're also giving you this like graph to show you sort of the curve of the frequency response that you've entered in here. But I think even more, I said that this was a project that really taught me JavaScript. So I think even more than learning what it takes to make great UI and all the actual like underpinning engineering effort that it takes, it actually has taught me how to achieve those engineering means. So by having this very explicit goal of like, I am going to re-implement this thing, and I know it's worth doing because I've seen it and it's great, has really been a great inspiration to me to drive me to actually solve some of these problems. I know they're solvable, and I know that they're worth solving, and I just have to sort of connect the dots. It's kind of like when you have, this is going to talk about testing here. It's kind of like when you have a red test, and you know that like my only task right now is to make this test green. And I think it really focuses you and helps you know, like, I know what I want to work on, and it's this exact thing. And so having a sort of perfect spec in the thing that you're trying to imitate can be really helpful. So I'm going to take one very challenging example and talk about some of the things that I learned by having to force myself to solve this problem. So for those of you who remember Winamp, one of its sort of canonical things was you could theme it. It had these skin files. And it would basically change how the entire thing worked. And so, of course, I had to re-implement that. And so you can go to your file system and bring in a skin, and you can see everything changes. You can see the sliders change, the colors change, everything is different. But how do we do that, right? We're given this binary format, we're in a browser, how do we solve this problem? So first, I'm going to step back and show you what a skin actually is. So skin, it has a .wsz extension, but under the hood, lucky for me, it's actually just a zip file. And look, there's a JS zip library that I can npm, I can yarn install. I didn't say npm, did I? And inside of it, what do we have? So there's a set of sprite sheets. So maybe some of you have done like CSS sprite sheets. You're familiar with these. This comes from video games, I think. But so here we're looking at this individual image here. And we can see it's a single image, a BMP file, but inside of it is a number of smaller images. And so we have to find some way to get all of that out and usable in our UI. So the first challenge we have is like we've got this raw data that we've got out of our JS zip library. and we need to get it into an image tag. So luckily, we can do that. We can construct our new image here, and then we can use URL create object URL to create an object URL and wait for it to load. And now we have basically a promise, which gives us our image node. Okay, that's great. So we have our image in an image node, but we need to now extract the individual sprite. So some of you who are used to doing CSS spriting might know that sort of the traditional approach is you take the image and you set it as a background, and then you have your div that's sized, and you set the offset of the background, and you sort of create this window where you're seeing through into just the one sprite image that you want. And that works great, and I thought I could do that, but it turns out that you cannot do tiling in that way. So you can't have a single sprite image which repeats, because you get the whole sprite sheet repeating. So I actually have to extract the individual tiny image. And so again, I had no idea how to do this, but I learned a lot about JavaScript. And so you can construct a canvas, and you can set the height and the width of that canvas. Then you can take your image, which you extracted from the zip file, draw it into the canvas, and then you can extract a data URI, which is just a string, which you can use as a URL of that individual sprite sheet. So we're getting closer. So this is what we've extracted. We've gone all this effort, and we've finally got one tiny image. And then there's another problem, which is that you can't use JavaScript to style pseudo elements. So hover or the slider or the handle on an input slider, you can't style any of those things. So again, I was like, okay, I got to learn some more things about the web. And the only solution that I was able to find, and if you have a better one, do let me know, was to manually construct CSS string. So what we end up actually doing is we've got this data URI on the left here, and we can just manually concatenate up a CSS string. And then we can inject that into the DOM. So overall, this is just like a stack of hacks, right? Each of these things is kind of awkward, and you probably in most cases you shouldn't really do that. You should find a better solution. But having this constraint of trying to re-implement this exact thing, I think really focused me and gave me really interesting problems to solve and great things to learn that I think if I had just started my own project, I'd be like, I'm going to make a to-do app. I would not have gotten to solve all of these interesting problems. And I think other art forms have a tradition of this, of studying the great masters and sketching the great masters and impersonating, covering the songs of the great of musicians. And I don't really see that so much within engineering. I think we're always ready to jump onto the next thing. But if you're looking for a side project, I would just encourage you to think about what you might be able to get out of imitating another application that you love, and the kind of inspiration and that kind of constraint can set for you. That's all I have, but I do want to show one more thing, which is as of yet unreleased on webamp.org. But one of the most iconic pieces of Winamp for many were the visualizations.
This is dangerous. I walk through my fields and watch your head rock.
Thank you.
Wow. That is outstanding. Thank you for showing that project. That is so cool. That really takes me back. So I think, do you know how long we have this room for? 10? Oh, wow. Oh, cool. So if you want to stick around for a little longer and chat with us, then please feel free to stay. Thank you so much for coming. I really had a good time, and I hope you did too. Right.